Hi gents, welcome back. We're gonna move on from 4F, and I just want to say thank you. Several of you got in touch just to point out that there was a small little calculation error just at the end of the video. So I appreciate that when you were looking out for it and you were interacting with it and all the rest. So thank you for getting in touch. It's encouraging to see. We're going to move on to a leaving cert question. So as you can see, this is 2014. Question 2. So this is your first attempt at a leaving cert rel question. What I suggest you do is you pause the video, you give it a shot, because it's your first time doing a leaving cert question. So it's good for you just to try it first, just to see how far you can get, and maybe you can do the whole thing. But unlikely on your first go, especially because when you've been doing 4F and 4E for a while, you really tend to forget 4A quite quick, at least I find. Okay, what does it say? 3 ships, X, Y, and Z, are observed from a Coast Guard station at half-hour intervals with distance measures in kilometers and speeds in kilometers per hour. They have the following displacement. So at 2 p.m, this is where X is. And every hour it's doing that. It's moving over 4 and it's moving up 5. At 2:30, Y is here and it's doing this every hour, and at 3 p.m. Z is there and doing that per hour. Prove that if X and Z continue with their uniform velocities, they will collide. Find the time of the collision. Okay, what we should be doing here, I think, is probably a good idea, is to have a look at where these things are at the same time, at the exact same time to each other. So as it stands, well, we're only interested in X and Z. So what we could do here is we could say, where was Z at 2 p.m, like roll back an hour. That's where it is at 3 p.m, and we know that it's doing this every hour, so we could just go back an hour very easily. With X, we know it's here at 2 p.m, but if we want to know where it is at 3 p.m, to compare it to Z, we know that it's doing this every hour, so we could let the hour just roll on. That'll be fine to do. It doesn't matter which. You can bring Z back an hour, X forward an hour. We'll bring X forward an hour, I guess, just because we can compare the two things nicely together. So we want to say, where is X at 3 p.m, just to have an easier way to talk about it. Well, its velocity is still going to be 4i plus 5j. Okay, nothing changing there. But where was it? It was at 2i plus 7j. So in 1 hour, we know that it moves over 4. So it's going to be it's going to be at 6i. It's already at 2i, so it moves over 4, 6i, and it's at 7j, and it's going to move up a further 5j. So it's going to be at 12j's. So that's where it will be at. Just a little reminder for myself. Just while it disappears, this is displacement and this is the velocity. Okay, how do we show that they're on a collision course? Well, there's 2 ways to do it. Your book has one way, and I also want to show you another way to do it. So let's get stuck in. The book says that. Do I want it to be that one? Maybe that's a bit better. Yeah, I think that's a little easier to see. So it says that if we take the velocity vector of x relative to z, I'm doing a straight x, so we'll relative to z. If that vector is equal to minus k, where k is a positive number, times the displacement vector of x relative to z. Okay, if you can show that that is true, if you can take this thing here, multiply it by minus a positive number, just say minus number, and you get this thing here, then they are on a collision course. So let's go and find that out there. So we know that this thing here, the velocity vector of x relative to z, well, we just get the x one and we subtract off the z one. Okay, so the x1, we can see it there. It is 4i plus 5j. No problems there. And in fact, no need for a bracket really on that one. And we're subtracting off the z1. So we're subtracting off 2i plus 6j. Okay, so it's going to be 4i minus 2i, that's 2 i's. If you've got 5j's, take away 6j's, you've got minus j. Okay, that is what we are dealing with there, and now we have to do the same for the displacement vector. So The one of x relative to z, well, it's just the same. It's just the x1 minus the z1. Okay, now what's our x1? So this is our displacement one. So it's 6i plus 12j. And we are taking away the z1, which is 12i plus 9j. Okay, so x relative to z, displacement. It's going to be 6i minus 12i is minus 6i. And then if we have 12j and we are taking away 9j, we've got plus 3j's there. So the question is, can we write it as vxz equal to minus k times or xz? Can we say that? Okay, so is 2i minus j equal to minus, and we got to be able to place a number in here, and it should give us minus 6i plus 3j. So I think you can see what you would need to multiply by. You would need to multiply by minus 1/3. Okay, that would get it for you. Minus 1/3 times 3j is minus 1j, and minus 1/3 by minus 6i is 2i's. So it is absolutely consistent, and we can say therefore on a collision course. When did they hit though? That's the next question. So the time in which they hit, it's equal to the relative distance. So we want the distance over the relative velocity or speed. Okay, so we know what the distance is. This is our distance. This is their relative distance. So if we just get what that is, the modulus of it really. So it's minus the square root of minus 6 squared plus 3 squared. That's what the distance is, and we want to know what is the velocity. And the velocity is the magnitude of 2 squared plus minus 1 squared. Okay, that's coming from over there. So what's this equal to? Well, you can just use a calculator, I guess, but it's, you know, you're applied mathematicians, so you should be good at this. 36 plus 9 over root, that's going to be 4 plus 1. So we get that the time is equal to root 45 over root 5. What are you allowed to do here? One really incorrect thing to do is to square the top, square the bottom. An absolute no-no when it comes to a fraction. Because if you think about it, if that was allowed, if you can square the top and square the bottom, then this nonsense would be true. So you can't do that. You can instead break down root 45 into root 9 by root 5. So how many root 5s do we have on the top? We have root 9 of them. Root 9 of them is 3. It takes 3 hours. Okay, it takes 3 hours for that collision to occur. And remember, that was from 3 p.m. So 3 hours from 3 p.m. It asked specifically what time does the collision occur. Occurs collision occurs at, well, we'll keep it to 24 hour time. Okay, that is that's the way that the book does their examples. What I'll do now is I'll just show you a different type. I'll just clean this up first, so I'll just pause it here back in a sec. Okay, I just want to show you a second way to do it. I've cleared that up now. Just a second way to look at it, which I think is a whole lot better, dare I say it, than what the book has done. Not to cast too many judgments. This is what I would do. I would have, again, the two things at the exact same time as each other. Okay, so we now compare perfectly. And what I will be saying is this. I would be saying that, for instance, x. What's x doing? Where is it? It's at 6i plus 12j. That's where it is at this exact moment. Where will it be like in an hour? Well, what's going to happen to it is it's going to be doing 4i plus 5j. That's going to be added on. How many of those will be added on depends on how many hours. So in 1 hour, we call it t hours. In 1 hour, you'd be adding on 4i plus 5j. That's where it would be. In 2 hours, you'll be adding on, 8i plus 10j. So you just do 2 of the 4i plus 5j. So that's where it's going to be, okay, in the future. And you just do the same thing with z. Okay, where is it? At the moment, z is at 12i plus 9j. Where is it going to be? It's going to be doing 2i plus 6j every hour. So that's where it's going to be. And if we have the two equal to each other, that just means when are the two things going to be at the exact same place. Okay. So there's a couple of ways that you can go about doing this. I think I have a nice little way to think about it. So first thing we'll do is we'll subtract 6i minus 12j from both sides, and we will end up with 6i here. And when we take away 12j, we will have minus 3j's there. Okay, and here we'll have 4i plus 5j by t, and we're going to take away from both sides 2i plus 6j, that many t's. Okay, taking that away from both sides. So essentially, brought this bit here, I brought that left, or sorry, I didn't. I brought this thing here over there, and I brought this thing there over there. Okay, simple enough, I would think, if you're doing applied maths, hopefully. Okay, so here we have, like, just imagine, this looks a little bit scary, but let's say it was 7t minus 3t. You just do 7 minus 3, and that's how many t's you have. So it's the exact same thing here. We're just going to say, how many t's do we have? Well, we have this many minus that many, so I'll just do this number minus that number. So it's going to be 4i minus 2i, so it's going to be 2i, that's how many i's we'll have, and we'll have 5j, and we're taking away 6j, so that'll be minus 1j, and we've seen these numbers before. Okay, and it's equal to 6i minus 3j. And remember, t was the number of hours that we were letting progress. So if we want to get what t is, it's just 6i minus 3j over 2i minus j. Let's divide both sides by 2i minus j. Now we can see for sure, first of all, that they are going to collide, because one thing is a multiple of the other. So you should be able to factorize the top, and you can see here that if we factorize out of 3, we'll get 2i minus j. Okay, and down here we will have 2i minus j as well. Okay, so it should be, for instance, that with the j's, oh yeah, I'd have to multiply by 3 to get that one. If they weren't on a collision course, for instance, then if you multiplied 2i by 3, you wouldn't have a 6j up on top. So for instance, if you had 7i minus 3j, just to make this really clear, here are two things. This is an example of something where there is no collision course between them. How do we know? Because we'd have to multiply that by 3 to get up there, but multiplying by 3 does not give us the right answer there. So it should be, if you have a collision course, so we've now proved that there's a collision course, and it has the advantage that it just divides in to tell us what t is. How long do we have to leave it run? And it tells us that if we leave it for 3 hours, the collision will occur. So we're getting 6 p.m. or 1800 hours out of that. I like that method. It's quite a nice way to think about it. It's very simple. You can verify your answer quite quickly. I think this was our x one, yeah. So where is x at the moment? It's at 6i plus 12j, and it's doing 4i plus 5j every hour. So if you leave it 3 hours, we're going to have 6i plus 12j, and we're going to be adding on three amounts of 4i, so we'll be adding on 12i, and we're adding on 3 amounts of 5j, so it's 15j. So where will this be in 3 hours? The place where it will be is 18i plus 27j, and then you just verify it over on the other side with z. It's currently at 12i plus 9j. What's it going to be doing? It's going to be doing 3 amounts of 2i, so that's 6i, and it's going to be doing 3 amounts of 6j, which is 8j. So where is it going to be? It's going to be shocker 18i plus 27j at the exact same spot in 3 hours, i.e. colliding with each other. That's I think it's important to see that second way and not just the first way. Because I don't know, it's just a little bit easier to think about. I think the setup for the other one is a bit more tricky. So I think some of you will prefer to do that. Okay, I'm going to move on to the next part in just a second. Okay, we'll get on to part 2 now. It says at the instant of the collision, ship Y changes course and then proceeds directly to the scene of the collision at its original speed. Find the time to the nearest minute at which Y will arrive at the scene of the collision. Now remember, this is where the collision is taking place. This is the handy part of doing it the other way. We were able to verify that, although if you had done it the original way, you could get that answer pretty quickly as well. Okay, so a couple of things to do. First of all, let Y continue on up until 6 p.m. Let Y do what it was doing that whole time. Okay, so where was it? It was at, we'll zoom in a wee bit here. It was at 6i plus 9j. That's where it's at. And remember, it is doing 3i plus 4j's every single hour. Okay, now, if it's doing that per hour, what we have to do is it's at 2:30, so we have to leave it run for 3.5 hours in order to bring us up to the moment of the collision. So this is just to see where is Y in 3.5 hours. Okay, so it's going to be 6i plus 9j, and it's going to be, we'll do 3 times 3.5, so that's 10.5. You can use fractions if you want to, plus 4 times 3.5, which is 14j's. Okay, so at the moment of the collision, where is it? That's really what we're getting here. So it's 16.5i, and it's 23j's. Okay, this is where it is. That's where the collision is. So the question is, how long is it going to take if it sails directly to it? Okay, so what we want to do is the time taken will be equal to, we already did this before, it's equal to the distance between the two things. So it's the distance, and it's divided by the speed or the velocity that it's doing. Okay, so the distance between the two things, we can measure it on the i's and the j's, but to get the actual distance, then we're going to have to do Pythagoras' theorem on it, basically. It's like the distance between 2 points using coordinate geometry or something like that. So the distance is 1.5 squared added to 4 squared. Maybe, I'll just take a quick little second just to talk about what am I doing here. So just imagine I've moved over 16, I've moved up 23. Let's just say that's there. Okay, this is where, which ship was that? That was Y. And if we move over a little bit more and we go up a little bit higher, that is where the collision, we'll call it C, is. What am I doing here? I'm essentially finding out that we had moved over 16.5, but the collision itself is over 18, so this gap here is 1.5, and we go on the way up. It's up 23, but the collision is up 27, so this is 4. So that's what I'm doing. I'm getting this distance here, getting that distance there using Pythagoras. Maybe it's just worth doing that out rather than like just saying it or something like that. Okay, what is its speed? Well, it hasn't changed its speed. Y hasn't changed its velocity, and Y was doing 3i plus 4j, so that's 3 squared plus 4 squared. I think we can all remember that one's going to be 5. It comes up so often. Okay, I am going to need a calculator, which I have over here. So let's see. So this is going to be 1.5 squared added to 4 squared. So this is on top. the square root of 18.25, and on the bottom that's just going to be 5. So we'll do the square root of the answer, and we'll divide by 5. This will tell us the time taken. So the time is equal to 0.8544 something something something. It wants it to the nearest minute. Okay, so it's that, and it's that many multiplied by 60. So it's that amount of an hour. So it's 0.85 of 60 minutes. And that for me comes up to be time equals the nearest one. It's 51.26 minutes. So to the nearest minute, it will take 51 minutes for y in order to reach the collision site. Okay, so that's the A part. The B part is pretty much a totally different thing. I'll get onto that in just a second. Okay, gents, that's the A part. I've filled in the B part. We were just missing a bit of it, but I think what I will do is I will pop this into two videos, because it's going to be too long a video otherwise. Okay, we'll do the B part in just a second on a separate video. Thanks.